Hi, and welcome to the second day of second semester Algebra 1 summer school. Today's main learning target is to be able to identify, analyze, and write arithmetic sequences. So, an arithmetic sequence is a sequence in which the difference between any two terms is constant. So the terms in the sequence, if they are changing by the same number being added each time, that's going to be an arithmetic sequence. In an arithmetic sequence, you have a common difference. That is the numerical difference between two consecutive terms. And we use a variable to represent the common difference. We use the letter D to represent difference. And that's going to come in handy when we start to write the formulas for these particular sequences. So, first piece we want to do is to be able to identify an arithmetic sequence. So, in this first set of problems, we're going to determine whether the sequences are arithmetic. If they are, identify the common difference. So I'm going to do examples 2, 4, and 6 for you. Problems 1, 3, and 5 are part of your independent practice for today's assignment. So let's look at example number 2. When we're looking at these sequences, in order for it to be arithmetic, we need to add or subtract the same amount from each term. So to get from 1 to 3, I added 2. From 3 to 5, I added 2. But from 5 to 8, we added 3. So this is not an arithmetic sequence because that common difference changes between the third and fourth terms. Okay, let's look at example number 4. To go from -5 to -8, I had to subtract 3. From -8 to -11, we subtracted 3, and from -11 to -14, we subtracted 3. Since that difference is in common, or is the same, between each of those terms, that means that this is an arithmetic sequence, and the common difference is that value it's changing by each time. So the common difference is -3. All right, example 6. Same idea. From 7 to 6, we're going down 1, so subtracting 1. 6 to 5 is decreasing by 1. 5 to 4 is decreasing by 1. That has a common difference, so yes, it is an arithmetic sequence, and that common difference is -1. You are welcome to pause the video now to complete problems 1, 3, and 5 on your own, and then resume the video when you're ready to go on. Okay, the next task we're going to do together is continuing an arithmetic sequence. I'm going to do example 8 for you. So if we look at this sequence, we want to find the next 3 terms. So sequence 8 starts with 5 and goes to 2. Well, 5 to 2 is a decrease of 3. 2 to -1 is a decrease of 3. -1 to -4 is a decrease of 3. That means we have a common difference of -3. And I want to continue decreasing by 3 to get the next 3 terms. So -4 minus 3 is -7. -7 minus 3 is -10. And -10 minus 3 is -13. please pause the video now, complete problems 7 and 9, and then when you're ready, resume the video and we'll keep going. All right, in the previous lesson yesterday, we looked at the explicit and recursive formulas for sequences. This first formula we're going to talk about is for explicit formulas, which really are pretty darn useful. So that's what we're going to work on first. In order to write the equation, we need to define what variables we're using. So we're going to say D is our common difference. That's the amount we're changing by each time. And A sub 1 is the first term of our sequence. So when we're writing our equation, we're going to say A sub n. So the term of the sequence can be found by taking the common difference times the term number minus 1 plus the first term. The reason we want to take that term number minus 1 is because really we want to find what we have to start with in term 0 if it existed in order for our equation to work out the right way. So when you're writing an equation, you're going to need to figure out two pieces of information. You need to know what the first term is, and you need to know what the common difference is. Those are the two pieces you're going to have to identify for your sequence. So for sequence number 10, the first term is 7. Then if I look at how this pattern is changing, every time we are increasing by 6. So my common difference is 6. If we plug into our formula, A sub n is equal to the common difference times n minus 1 plus 7. Notice that A sub n and n stay in our formula when we're writing them. Now, that's not the most useful form. We can rewrite this in order to simplify. So we're going to distribute that 6 into the parentheses. So we get 6n minus 6 plus 7, and then we can combine those terms. So we get 6n plus 1, and that would be the formula, the explicit formula for sequence number 10. All right, now that we've found the rule for the nth term, the next piece we need to do is find the 19th term of the sequence. To do that, we want to plug in 19 for n. So we would take 6 times 19 plus 1, which gives us 115 as our 19th term. Same idea applies for all of these sequences. Go ahead and pause the video and try number 11. When you're ready, resume the video and we'll go to the next page. All right, on the previous page, we talked about writing the explicit form by saying A sub n is equal to D, the common difference, times n minus 1 plus the first term of the sequence. Yesterday, we talked about recursive sequences as well, or recursive formulas for sequences. We want to talk about what that looks like here as well. So with a recursive sequence, for an arithmetic sequence, we still want to define the first term. That's going to tell us where we're going to start. And then to find a sub n, we have to review or go back to the previous term. So really what we're doing with with an arithmetic sequence is you're taking that previous term and to it you're adding your common difference. So D is still that common difference. For this page, I'd like for you to write the explicit formulas, but you might see the recursive formulas down the road, and it might be helpful to have that information as well so you can compare them side by side. All right, let's do a couple more examples together just so you can see what's going on. And the directions for this asked us to find the, write the rule for the nth term, and then find the 19th term. Okay, so let's take a look at example number 12. We need the first term, which is negative 11, and we need the common difference. From negative 11 to negative 8, we are increasing by 3, and that pattern continues through our sequence, so our common difference is 3. So the rule for a sub n would be 3 times n minus 1 minus 11, which is 3n minus 3 minus 11, which is 3n minus 14. So that would be the explicit rule. To find the 19th term, we want to take and plug in 19 for n. Which gives us 43 for the 19th term in that sequence. All right, example 16. Our first term is negative 16. Looking through our sequence, I notice that it is decreasing by 5 each time. So to find our equation, we take the common difference times n minus 1 plus the first term. Distribute. Notice that when you multiply negative 5 times negative 1, it becomes positive 5. And then because the signs are different, we end up subtracting. So we get negative 5n minus 11. So that would give us our equation. Then to find the 19th term, we plug 19 in for n and evaluate. We get negative 106. Okay, go ahead and try 13 and 15. Pause the video, come back when you're done, and we'll move on to the application pieces. All right, let's go through number 16 as an example of an application. Basically what happens with an application is you still need to identify those key pieces of information. You need to know what the sequence is, find the first term and the common difference, and then be able to interpret that. So you visit the Grand Canyon and drop a penny off the edge of a cliff. The distance the penny will fall is 16 feet for the first second. That sounds like important information. 48 feet for the next second, and 80 feet for the third second, and so on. That is our sequence. The first term is 16, the second term is 48, the third term is 80, and so on. Makes us continue that sequence. So to write a formula to represent the sequence, we need to identify the first term and the common difference. Well, the first term is 16, and the common difference, if you take 48 minus 16, you get 32 as our example, or as our common difference. Our formula, a sub n equals that common difference times n minus 1 plus the first term. Distribute. So we get 32n minus 16 is our formula for the sequence. How far will the penny have traveled after 6 seconds? Well, 6 seconds is really asking us to find the 6th term of our sequence. So to find the 6th term, we're going to put 6 in for n and solve to find our answer of 176 feet. Will be how far he has traveled after the 6 seconds. All right, example 17 is yours. Go ahead and complete that problem. Once everything is done, submit your work to Google Classroom. Then you may move on to the formative assessment. Thanks, guys. Have a great day. Good luck. We'll talk to you soon.